Find smallest letter greater than target. You are given an array of characters, letters, that is sorted in non-decreasing order, increasing order, and a character target. There are at least two different characters in letters. Return the smallest character in letters that is lexicographically greater than target. If such a character does not exist, return the first character in letters. So my first thoughts with this problem is that they emphasize the non-decreasing order, which means it is sorted. And also this problem was given from our teacher, and she mentioned binary search, which is relevant only when something is listed. And it seems that the letters that we're given is listed in an ascending manner. So I would assume the topics we cover in this problem will be likely to be binary search related. And they are saying that we are going to have at least two different characters so that we don't have to worry about the edge case of having a zero length letters. Let's take a look at the topics. Binary search, array, mid-level. So the way that I would reword this, if I had to explain it to someone, I would say that given the target character, in this case A, from the given list of characters, C, F, and J, which of those is the smallest lexicographically, which just means that it's closest to the target character, which is A, and this is already sorted, so we just have to basically come up with the smallest or the earliest appearing character that is closest to A. In this case, it's the character C. All that to say that we are finding the smallest letter greater than the target, which is literally the title of the problem. I was looking for questions to ask if this was an interview, but these constraints seem to cover most of the ground pretty well. That it's gonna be English letter, all lowercase, sorted in increasing manner, and that there's at least two different characters. As for edge cases, feels weird to call them edge cases, but I'm guessing if, like in example 1, if the target is smaller than any given character, I'm guessing you just bring it forward, which is C. Or if it's bigger than any of the characters, then we just give them the biggest character we have. Another one is, let's say we have XX and YY, just like in example 3. But if the target was X or Y instead of Z, then do we output Y? Oh, well, yeah, we would give Y because it's the smallest letter that is greater than the target. And then if they said Y, then I'm not sure. If they say Y is the target, well then we can't give them anything from this list. So we just revert back to the default, which is that we just give the 0th index. So we just give them X. So for my approach, the first thing that I would try to take care of is if the target is bigger or smaller than the given characters we have, I would identify those quote unquote outliers and then just return whatever that's closest. And also, if the target is Z, because Z is the last character, there is no character that is greater than Z, so we just turn first index, 0th index of this character letters. My biggest concern or question that I need to resolve is how do we map out which letter is lexicographically significant? Like, how do we put values to them? Or do we just literally do like switch cases? But knowing that we are using binary search, maybe if I search that, something might pop up. I'm just unsure how people go about assigning values to characters, or if there's some sort of like built-in ASCII like programmer thing that is there to help us with this particular challenge, because like, to English speaking humans it is pretty obvious that B comes after A, C comes after B, so on and so forth. But how do we teach computer those lexicographical values without hard coding it in array or dictionary, or are we supposed to do that? But once we can determine such concept, then I think we can then start on the binary search. So cutting right into the middle, and then comparing it, and then moving the index accordingly if it's smaller or bigger type of thing. But maybe I will start with search for that question of how do we know how much each character is worth. So I'm looking up the relationship between the English characters and if they happen to have a numerical value. And it says that ASCII does have something and the Unicode. I don't quite know how those work, but I'm sure someone's already done the work and you just have to understand how that works to use it. And I guess like previously we had this concept of, 48 was 0 and 49 was 1. Like I forget which problem, but we learned that and I was like, who knows that stuff unless you're a programmer. So I feel like I have to figure out the values of all these characters. Maybe if I see the table, I'm guessing the lowercase and the uppercase are different. Okay, so 97 marks the start of it, and it goes up to 122. So I think that's a starting point. So 97A goes up to, and also they mentioned that these are all in lowercase English letter, if that makes a difference, which I think it does for ASCII values. 122 is Z. So next step would be translating those values to these numbers so that we can apply those logical operators for comparisons. But before we go further, let me start with the if target is equal to z, we are just going to return the 0th index of letters. Alright, so that part does work. How to convert a character to ASCII value. What would be the most elegant or delicate way to kind of process all of these at once? I wonder. In terms of space complexity, there's no way that we should make a whole another character array or character list of letters just for the ASCII values. Okay, so I think we are off to a okay start. So we took care of the case in which we get z, which is greater than anything, and we also took care of anything that is smaller than anything that is greater than we have, everything we have. So the next step is to address anything in between. I want to say, let me just revisit what binary search syntax looks like. So I think we need to start by setting the boundaries. So let's do just that. And I remember asking this exact question, why not just left plus right divided by 2? And there was some weird shenanigans with number system that made this the right way to do this, which I'll have to revisit. We have to address if the target is the same as one of the values. Okay, not even close. So after wrestling for quite a bit, I managed to get it run. I had to take care of the edge case a little bit to greater than or equal to the biggest element in the letters array, and if the very first element was the same as the target, then what are we gonna do? We just kept incrementing until it was not that. I realized that there was like an error in the logic. Initially I was just returning anything that came right after it, but of course Leetcode is smart enough to tell us that that's not gonna cut it. And while wrestling with various logic, I came to the conclusion that this is just, we have to move on in order to get to the answer. So it says that runtime is good, but the memory is pretty pathetic. So I'm gonna put my code into Claude and ask for evaluation. Okay, so the core binary logic that I got from Google is sound, thankfully, and that I did take care of the wraparound case. But the biggest issue is that I over-engineered the edge case handling. So I guess I made that unnecessarily. The post loop while is wrong and dangerous. Yeah, I noticed that I was working way too hard to account for every situation, and that's when you know for a fact that yeah, something was wrong, like I'm doing too much. um I think I was just trying every way to have the code pass the test. By the time you exit the main loop, left already points past any duplicates of target. Yeah, so I think I made those adjustments before making the final adjustments. What we just found out through revising with Claude was that all that edge case handling was unnecessary if our binary search was clean. So I basically combined two of the if statements since our post logic check action was the same, and then final piece was instead of just returning the left index of the letters, it is left ampersand so that like it's not right at left but like right after left. And I guess I found out today that you can compare characters without having to convert to int. So today we tackled the problem finding smallest letter greater than target. In a way it was easier than I thought, but at the same time it was harder than I thought it would be. So I thought the whole conversion from character to number was going to be a problem. But what actually troubled me was a lot of the edge cases that Leetcode came up with a bunch of awkwardly sequenced characters where they would repeat a certain number of times, and I had to ensure that all of those are taken care of. And until I found the right logic, all those like edge cases were just making it messier. A lesson that I can take with me is to just take a step back if I'm having to make too many edge case scenarios and just, look at it again from a step further back and see if there's something that can catch all the other scenarios by itself. As for the concept of binary search, I think I felt a little bit more comfy today compared to the first time I saw binary search. Definitely nice to have that extra rep in. Today I actually tried to spend more time debugging everything myself and trying to find ways to make the code work instead of just, having a timer and then when the timer runs out, check what Claude says. While that is easier on time management aspect when it comes to the rest of my day, I think in terms of like pure learning, it is healthier for me and my growth to just sit through and suffer and try to get to the answer myself, which I knew already, but it definitely takes a lot more time to do all the problems that way. But just something to keep in mind. Oh, and relating to that whole aspect of having to troubleshoot for a long time that made the code messy, I think it would benefit me to take some more time looking over, proofreading the final version of the code before submitting if this were like a real interview, so that some of these commented out code that was more of an accessory and a useless one at that. If I knew that my code is handling those edge cases now, then I wouldn't need them anyway. So just before submitting it, just make sure to clean the code up, I think is heavily felt in this particular problem. But I think that is it. Thanks for watching, and if you have any feedback, please feel free. Until next time, take care.